So here is that example of a pulley inside of a lift. Two particles of mass 6 and 7 kilograms are connected by a light string which passes over a smooth pulley, which is attached to the ceiling of a lift. Find the tension in the string, given that firstly the lift travels upwards at a constant 2 meters per second, and secondly the lift accelerates upwards at 2 meters per second squared. So the first case should be fairly straightforward. If you've done enough of these pulley problems already, it should be straightforward. Part 2, I would watch the solution for. So go ahead and give this problem a try, and when you're ready, come back for the solution. So here is what is happening. So I won't be going through how to get g over 13 and 62.3 newtons here, because that should all be fairly straightforward at this stage. We're just going to focus on this bottom part. So our pulley is accelerating upwards at 2 meters per second squared. Now the 6 kilogram mass is already accelerating upwards, so the 6 kilogram mass will be faster, or will accelerate faster, whereas the 7 kilogram mass will be accelerating slightly slower. In some cases as well, it can actually be negatively accelerating, so it actually accelerates in the complete opposite way it normally does. This will actually happen in this case if you plug in our new acceleration, which I've denoted as alpha. So our first one, the 6 kilogram mass, will accelerate at alpha plus 2 meters per second squared. So with the resistive inertia of the moving lift, the acceleration will indeed change. The acceleration of the 7 kilogram mass is alpha minus 2. So after solving simultaneously here, we get that g is 6 alpha plus 12 plus 7 alpha minus 14. So g is 13 alpha minus 2, which implies that alpha is g plus 2 over 13 meters per second squared, which is about 0.9 meters per second squared if you're taking it just to that. So 0.9 meters per second squared. The tension in the string we can find with 6g plus 6 lots of alpha over, or alpha plus 2. So the tension in the string, therefore, has indeed increased, as we've perceived. It's increased to 76.2 newtons. So that's how to solve problems with pulleys and elevators, and congratulations, you've finished off the playlist for forces and dynamical systems.